Here we go. Our objective for today, I can identify the direct variation of a relation. Let's read together. 1, 2, 3. I can identify the direct variation of a relation. So with red, make sure you circle, underline, identify. And with green, make sure you circle or underline direct variation. Okay? So we're still on two variable equations. We're still on two variable linear equations. The only thing today, we're going to use a different form called direct variation. So you're saying, what is that, Mr. Q? Well, let's figure it out. Here you go. Here's the Fourier model. Direct variation form. It says, a special type of linear relationship that can be written in the form y equals kx. Can be written in the form y equals kx, where the k is a non-zero constant called the constant variation. So therefore, k cannot be what number? 0. It cannot be 0. It has to be any other number. Okay? And it has to be in this form. So with blue, I want you to overlay the letter k with blue and underline with blue where it says constant of variation, so that you know that the k stands for what? The constant variation. So let me give you the examples, and you already have them written down on your Cornell notes. Y equals x is a constant variation, a direct variation. Y equals 3x is a direct variation. Y equals negative 2x is a direct variation. Y equals 3/4 x is direct variation. And 5x equals y is a direct variation. Let's find out if they do look alike. Look at this. Y equals kx. Aren't all these the same as that one? Yes. So therefore, look at this one. Y equals 3x. It's exactly like this one, but instead of k, what does it have? 3. So guess what? The constant variation for this one is number 3. Look at this one. Y equals negative 2x is the same as this, except for instead of k, we wrote what? Negative 2. So my constant variation is negative 2. Let's look at this one. What is my constant variation? 3/4. What is my constant variation on this one? And what is my constant variation on this one? 1, because the coefficient of x is 1. So does everybody understand that the constant variation is the coefficient of x? Yes? And it has to look like this, or else it's not a direct variation. Let me give you non-examples. Write these down, please. Y equals x plus 1. Y equals 3x minus 2. Y equals negative 2x plus 3. Y equals 3/4 x plus, minus 5. And 5x plus 2 equals y. So these look very, very similar to these. Look at them. Don't say it out loud. These are examples. These are non-examples because they have something in particular that they make them non-examples. So examples, non-examples. So think about it. So now that you thought about it, what makes these non-examples? Talk it over with your neighbor. So yeah, if you see here, there's addition, subtraction, addition, subtraction, addition. So as soon as you see addition and subtraction involved in that equation, it's no longer a direct variation. Okay? So therefore, critical attributes. Number 1, it's a two-variable equation. Is that correct? So it's a two-variable y-form equation. And the other thing, it does not have a constant. Does this one have a number at the end? No, that's what we call a constant. It does not have a constant. All these non-examples do have a constant. So therefore, a direct variation form does not have a constant, and it's a two-variable equation in y form. Copy that? All right, steps. I give you guys 3 basic steps. Number 1, solve the equation for y or identify the pattern of a table. So we're to circle and underline. First step, solve for y if it's an equation. If they give you a table, you're going to identify the pattern. So for step 1, 2 critical things. Solve for y if it's an equation. If they give you a table, you identify the pattern. Step 2, identify if direct variation. Identify if it's a direct variation. And step 3, identify the constant variation. And at the end, I want you to write the letter K, because that's what we're going to be looking at in regards to the form. So let's see, once again, solve for y, identify the pattern. Identify direct variation, identify constant variation. So 3 basic steps. Step 1, solve for y and identify pattern. Step 1, solve for y, identify pattern. Step 1, solve for y, identify pattern. 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 Step 2, identify if it's the direct variation. Identify if it's 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 direct variation. If it is direct variation, step 3, identify the constant variation. Identify the constant variation. Identify the constant variation. Identify the constant variation. Let's see all together. Step 1, solve for y and identify pattern. Step 2, identify direct variation. Step 3, identify constant variation. Okay, tell your neighbor the steps, please. Fairly simple steps. Let's go with example number 1. Copy this down, please, and copy the text. It says, copy this down. Tell whether the equation represents a direct variation. If so, identify the constant variation. So copy all that down, please, for at least this first example. Tell whether the equation represents a direct variation. If so, identify the constant variation. And they give us the equation y equals 3x. Okay, pay attention, please. Pens down, eyes up here. You'll finish copying in a little bit. Here it goes. So, it says, tell whether the equation represents a direct variation. So let's look at our steps that we just wrote. Solve for y. Is it an equation? Yes. Is it solve for y? Yes. Step 2, identify direct variation. Does it look like this? Everybody look up. Y equals kx. Yes. So therefore, it's yes, a direct variation. If it is, what is step 3? Identify the constant variation. So what is my constant variation? The k. K equals 3. Copy that, please. That's it. Okay, any questions with example 1? Fairly simple, right? All right, let's copy this one, example 1b. See if we can do that one. We'll do this one together. Copy it, please. You don't need to copy the black text. Just copy the equation 3x plus y equals 8. Copy that, please. Okay, let's do this one together. Here we go. Guys, step 1, solve for y. So therefore, I need to get rid of this x. Is that correct? So I subtract 3x, subtract 3x. We're left with y equals negative 3x plus 8. Let's look at it. So, step 2, identify if it's direct variation. Let's see, here's my form, y equals kx. Does it look like this? No, so this is not a direct variation. And since it's not, we don't do step 3 and we're done. Okay, copy this next one down. Example 1c. Copy that one. See if you can do that one by yourself, please. Okay, let's see. Here it goes. So, we need to solve for y. We need to solve for y, which means we need to get rid of the x. So therefore, we add 4x to each side, add 4x to each side. We're left with 3y equals 4x. What's my last step? Divide by 3. Divide by 3. Y equals 4/3 x. Step 1 is done. Step 2, identify if it's direct variation. Let's see. Y equals kx. Does it look like this? Yes. Yes, so this is, yes, I'm just going to write dv for direct variation. And what is my constant variation? K equals 4/3. Okay, copy this next one, please. See if you can do that one again by yourself. Go. 3x equals -4y. See if that one's direct variation. If so, find the constant variation. Here we go. So step 1, solve for y. Y is already by itself. The only thing we need to get rid of on that side is what? The -4. What is the -4 doing? Multiplying, so therefore we need to divide by -4. Divide by -4. We're left with -3/4 x. Let's see. Does that look like y equals kx? Yes, it's only backwards, isn't it? Yeah, so if I switch these around, it looks like this. Kx equals y, doesn't it? Doesn't this look like this? So therefore this is, yes, a direct variation. And what is my constant variation? -3/4. Okay? So far so good?
It's the whole thing?
It's the whole thing. So here we go. So with that said, to answer this question, we needed to do number one, answer to see if it's a direct variation. If it was, we write our constant variation, which is k. Okay? Copy this next one down, please. Here we go. Copy this table. Copy the table. You don't need to copy the words. Just copy the table. Yes. On the table, you're going to write rice, x, and then 1, 2, 3, 4 for the domain. On the y, we're going to write servings, y, and 5, 10, 15, and 20 for the range. We'll write that down, please. All right, guys, here we go. Number 1. Step 1 says solve for y or find a pattern. And when we found patterns for tables, who remembers that we wrote an equation? Y equals blank, x blank. So let's see. Think about it. Don't say it out loud. What's happening to x to get y? Something's happening to x to get y. Something's happening to x to get y. Something's happening to x to get y. Okay? So, first of all, if it's multiplying or dividing, it goes here in the front. If it's subtracting or adding, it goes in the end. So therefore, who saw that it's multiplying by 5? So therefore, that one goes right here. So my equation is y equals 5x. By looking at it, step 2, identify if it's a direct variation. Is this a direct variation? Yes. Since it is, yes, dv. What's my constant variation? 5. And we're done. Everybody see that? Okay. Copy this next one down, please. Example 2a. Copy the table, please. X, Y. For the domain, we have 2, 4, 6, and the range 6, 12, 18. Copy that, please. And see if you can do this one by yourself. Find the pattern. Write your equation. See if it's a direct variation. If it is, find the constant variation. Okay, let's see. We write y equals blank, x blank, and let's see what's happening to x to get y, happening to x to get y, happening to x to get y. Everyone, what's happening to x? Multiplying by 3. So does that look like y equals kx? Yes, so it is a direct variation, and my constant variation is 3. So far so good? Okay. So now we got using an equation, finding to see if it's direct variation. We got it using a table to see if it's direct variation. Now let me give you one more step. Here you go. Copy this one down. Copy this one down, please. Example 3a. Copy the black text. It says, the value of y varies directly with x, and y is equal 3 when x equals 9. Find y when x equals 21. Copy that, and then I'll go over it really quick. All right, pens down, eyes up here. Here it goes. Focus, or else you're going to not understand the homework, and this is part of the homework. Here it goes. Check this out. It says the value of y varies directly with x. What they're telling you is that this is a direct variation. you're no longer going to be looking for to see if it is. This is already a direct variation. So this is what we need to do in order to get this last part. Find y when x is 21. We need to write our y equals kx form. That's our direct variation because we already know that it is. Are we there? Next, I'm going to substitute the first two values that they give me, one for y and one for x, to this original equation. So for y, what am I going to write? 3. And for x, what am I going to write? 9. And I bring down the equal and the k. From there, I'm going to solve for k. So therefore, to leave k by itself, I need to divide by 9, divide by 9. And k is equal to 3 9s, which can be simplified to what? 1/3. So now that we found k, everybody look up, please. Now we need to substitute this back into the original. Here we go. And this becomes, check this out, y equals, and instead of k, what do I write? 1/3, and then at the end, x. Are we there so far? Now that we have our equation, now we can do this last part. So what am I going to substitute here for x? 21. So therefore, this becomes y equals 1/3, open parentheses, 21. And what is 21 times 1/3? That becomes 21/3. What is 21/3? 7. And we're done. Copy that, please. So, homework. Homework is on page 285 to 286. Numbers 1 through 35 odd. All right, turn in your homework on your way out. I want to see those tickets out, and have a good one. I'll see you guys tomorrow.